Hello. So our topic is still on measures of location. So as that mentioned in our previous video, so we can actually compute for deciles, percentiles, and quartiles. So in this video, this is the continuation of our discussion on measures of relative location. So as mentioned in the previous discussion, so we are also going to consider another example wherein what we are going to compute is the deciles. So this is the data for age. We have age 16, 16, 17, 17, 18, 18, 19, 19, 19, and 20. So as mentioned in the previous also, that this is arranged already from lowest to highest age. So in case that you are given a data and it is not yet arranged, make sure to arrange it first before proceeding to the computation. So let us consider now computing for D sub 3. This sub 3 is the 30% of our data. So this is 3n over 10, and this is equal to, our data is 10, so 3 multiplied by 10 over 10 is actually the third data. So in our data set, the third data is 17. So 1, 2, 3, the third data is 17. And what is the interpretation of this? 30% of the respondents are 17 years old and below. While again, if we will consider the upper 70%, then 70% of the respondents are 17 years old and above. So that is how to compute for decile. So you can also compute for this sub 4, this sub 5, this sub 6. So as you can see here, since we have our 10 data, so it means that this sub 1 is the first data, this sub 2 is the second data, this sub 3 is the third data, this sub 4 is the fourth data. So which means that 10% of the respondents is, the 10% is only one, so that is 16 years old. 20% of the respondents are 16 years old and below, but for our data set, as because we can already see that both of them are 16, then we can simply say that they are both 16, rather 16 years old. So it actually depends, the interpretation depends on the data set. But as mentioned again, in case that there is no data set available, then it is safe to say that, for example here, in case that there is no available data, so I'll remove this first. In case that we do not have available data and you are provided with the information that d sub 4 is equal to, for example, it is the eighth term and the eighth term is, let's say, 20 years old. So this is just an example. So to interpret this simply means that 40% of the respondents are 20 years old and below. So it is safe to state that, just in case you do not have the available data set. Or if we are considering now the upper 60%, then we can also say that 60% of them are 20 years old, because we do not have the data, so we cannot say that it is only above 20 years old. So we can still mention 20 years old, just in case, for instance, that 8 and 9 scores are both 20 years old. And so I'll just place a slash here, or above. because I do not have any idea if the ninth data is also 20. So, or all the rest are already 20 years old. So it is 60% of them are 20 years old and or above. Okay, so this is all for the deciles. So let us also consider percentiles. So how about percentiles? So for percentiles, this is dividing the distribution into 100 equal parts. So which means we have P sub 1, P sub 2, P sub 3, P sub 4 until P sub 100. Percentiles is also termed as centiles. So if you can see the symbol C sub 1, C sub 2, C sub 3, of course, this also refers to the percentiles or C sub 100. And of course, 1, because we are very much familiar with the percent, 1 means 1%, 2 means 2%, 3 means 3%, and so on and so forth. So for the general formula is, let's use P. P sub K, where Kn over, it is divided into 100 equal parts, so it is Kn over 100, where K is equal to 1, 2, 3 until 100. Okay, so how will we compute now for, let's say, um, K sub 1, K sub 2, or the 10% of the data? Let's K is equal to 10. If K is equal to 25, that is the 25% of the data. So if we have the data on, let's say, so we're done with the scores, we're also done with the age. Or let us also consider weight. So given the following weight, so let us also consider another data set. So the following are the weights of the student. So we have 30, let's say 32, 35. So this is in kilograms. 35 kilograms, 35 kilograms, 37 kilograms. So 1, 2, 3, 4, 39 kilograms, 41 kilogram, 41, 45, 47, 47 kg. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have the following weight of the 10 students. So if we will compute for K is equal to the 10%, so it's still, this is the 10%. So it's like we are also computing for the this sub 1, which is the 10% also of the distribution. So what is our K is equal to 10? So again, because we have the 10 data here, 10% refers to the first data. So just to compute for that, P sub 10 is equal to 10 times 10 all over 100 is equal to the first data, and that is 32. So 10% of the data is 32 is of weight of with the weight of 32 kilogram. But of course, because we only have 10 data here, then the first data means that, or the first students weigh 32 kilogram. Okay, so let us also consider, let's say, A is equal to 70. So this is P sub 70 is equal to 70 multiplied by, that's 10 over 100. So it means that the seventh score, so 1, 2, 3, 4, 5, 6, 7 is 41 kilograms. So for the interpretation, 70% of the students weigh 41 kilogram and below, or the upper 37 the upper 30% weigh, or after 41 is 45. So the upper 30% of the data weigh 45, above, rather, it's above 41 kilograms. So that is how to compute for deciles, percentiles, and of course, quartiles. Thank you for Thank you for watching. So we will again discuss other measures in a separate video. So let us just go back to our outline. So our next topic is probabilities and normal distribution. So see you in the next video. So thank you for listening. Thank you for watching.